and I'm the founder and CEO of Encrypgen. We're a Florida company, but we have we have international connections as well. Our lead developer, Maurizio Viviani, up here is from Italy, and we're also working with people in the UK. We're partners with Curlew Research, located in the UK, and Richard Shute from Curlew Research is with us today too. I want to tell you a little bit about our software and our vision. We think that genomics requires two things for the science to be fully realized, including the sharing of data among researchers and security and privacy of personal genomic data. Now, my background is I was an ethicist for more than a decade, and I've been on IRBs and ethics committees, and I saw all too frequently that the requirements for keeping data privacy for genomic data were fulfilled by things like locking disk drives in file cabinets. And to us, that's not a good way to pursue the science. It doesn't facilitate the science. So this is what we imagine. So imagine a cloud of genomic data that could be freely searched for important and interesting metadata. Now, the 1000 Genome Project and other public genomic projects realize it in a way. They put the data out there and allow you to do some good science with it, and it's being used. And it's pretty accessible. I mean, you have to use you can use browsers to view the data, and you can use FTP sites to download the data. But imagine that cloud also is a safe storage place for personal genomic data, where patients could upload their data from any one of a number of sources. You get a test by a commercial genomics organization or through your hospital or whatever. And we can ensure that it is safe and secure. They could choose when they want to share that data and with whom they wish to share it, and set a time limit for that sharing. So you could give a key to your genetic counselor or your doctor or hospital, or to a research group that wants to do some science using your genome. And you could set a time limit for the expiration of that key. And you would also be able to negotiate some sort of payment for the use of that data. Now imagine being able to reach out to any donor of that data in this cloud and ask permission for the use of that data. So you as a scientist, you find some metadata that indicates this group of people or any individual in it might be an interesting subject in your study. You could put out a request through a network to recruit that patient into the study and then do consent procedures through the network too. And what if those consent procedures could be appropriate to the jurisdiction of that donor, of that subject in your study. What the technology lacks, however, in current cloud data storage systems, we've seen in a number of different fields that typical cloud data storage is not impervious to hacking, as we think it's insufficiently secure, and we've seen large-scale hacks of things like Yahoo Mail, and of course the recent WannaCry ransomware attack. Those are real vulnerabilities in current data storage systems, and we think this needs to be solved in order to fulfill the vision we have for genomic science. So even de-identified public data, for instance in the 1000 Genome Project and other projects, is insufficiently de-anonymized or insufficiently de-identified. So there was a study, as you probably know, in which they took data from the Personal Genome Project and were able to re-identify about 40% of it. And that, we think, is another vulnerability and one other impediment to realizing a lot of the promise of genomic science using large data sets. So even if you're using a sufficiently even if you're using a cloud service that can be hacked, and that data is taken off and it's been de-identified, we feel you're vulnerable. And that data, since it can be re-identified, is a vulnerability. It's also unwieldy to scan and search for data across different sequencing platforms. And choosing a particular NGS platform might limit your integration of data from multiple cohorts later. So if you're doing a wide study involving a number of researchers or research groups, you got to make a decision typically early on about the platform you use in order to make sure everybody across that group is able to access and use the data. So current cloud-based data storage solutions are insufficiently secure, private, robust, verifiable, immutable, and platform agnostic. And as I said, locking disk drives in filing cabinets is not a good solution for the science. So what we've envisioned is a blockchain solution. Now, you've probably heard of blockchain if you've heard of Bitcoin. Bitcoin is a blockchain platform. It's the most popular and one of the earliest forms of the technology. And if you invested in it early on, you're probably very wealthy now. The reason that Bitcoin has gone up in value so much is that it is an extremely secure network. It is very difficult. Right now it would require the power of a small state, essentially, and to develop a coordinated attack against that kind of network because of the size of that network, because of all the people who have joined it. Blockchains are distributed, peer-to-peer, virtually unhackable, immutable, permanent records of transactions. They store data, and in our case, ours stores genomic data. The gene chain is a blockchain. So we've built a blockchain that can store genomic data and transmit that data across the nodes of the gene chain in ways that are more secure than typical transmissions of data through clouds because of the nature of blockchain encryption. So we're able to provide, we think, a much safer and much more private storage for that data. Now we have on top of that an open application layer. We're developing ours on the IGV browser, so you can browse the data on either side of the blockchain using IGV, but you should be able to adapt other visualization and analytics tools to the data. Individuals could deposit their genomic data to the gene chain for free. So if you're just a patient or you've gotten your genome done by Ancestry.com or 23andMe or one of these, you can upload that data. You store it there with greater security than carrying it around on a USB drive or keeping it in your pocket, because you could lose that USB drive. And you can access it at any time and provide keys to whomever you want to use that data. So if somebody makes a request on the gene chain, like a research group, or they found you as a possible useful member of a study, they can make a request for that data and you can share it with them for a limited time or for permanent if you want. You can also negotiate payments, because one of the nice things about blockchains is that they accommodate exchanges of all sorts, including payments. The gene chain, if you're part of the node, if you're a node on the gene chain, you're mining the gene chain, creating what we call gene chain coin, which is the coin of the realm for transactions among members of the gene chain. So research centers, universities, and corporations may purchase licenses. That's how come individuals are able to store their data for free. And we have a tiered licensing system based on the sort of client you are. And we think this will ease your collaborations. We think it'll encourage better use of the data, and it will help to better protect the privacy and security of that data. We'll also, as I said, be able to tailor consents for the use of that data to your location, to your jurisdiction. The gene chain allows immediate and permanent tracking of transactions on the gene chain, allowing for a complete and permanent record, an audit trail, in case of misuse of data. So we have several layers of security to ensure the privacy of data. Besides the inherent safety afforded by blockchains because of the strong encryption involved, we also use rotating reference genomes, compression algorithms, aided by deep learning software, and time-limited keys, among other security measures. And the gene chain doesn't care what the original format of your data is. So which platform you use for sequencing or how you wish to browse it. Use whatever browser you prefer, let the gene chain safely store and secure it. It is NGS platform agnostic. We think this is a revolution, and actually we can already see in other fields that the blockchain revolution is helping to develop new methods of security for banks, logistics. DARPA, for instance, is exploring blockchain technology for securing nuclear weapons. So there's a great deal of interest and there's a great deal of investment right now in this field. We believe that in the field of genomics, which, because it deals with a relatively straightforward data type, this is an ideal entry point in biology, but it can be applied in other fields as well. So besides genomics, we could adapt this to proteomics, the metabolomics, and other big data repositories in biological sciences and even outside of biological sciences. And anybody who becomes a node on the gene chain is helping to maintain it. So the nature of a blockchain network, and the reason it's so secure, is that the more nodes you have, the harder it becomes to hack. So we encourage the proliferation of nodes on the gene chain, individuals and entities that want to mine the gene chain, because in order to hack a gene chain, you have to take control of more than 50% of it. So that obviously the more nodes you have, the more secure the network is, and the harder it is to cause mischief with it. As well, miners, as I said, are producing a form of cryptocurrency that is the medium of exchange for transactions on the gene chain. So the gene chain is actually, this is something that exists in a nascent form. We have a blockchain running right now. You can stop by our booth on booth 122. You can see a live demo of what's going on. It is populated by data from the 1000 Genomes Project and other public data repositories, and we are mining it currently, so you can see that in action. There are features that I've discussed as future features which we want to see, including the consent procedure that we are still working on, but the gene chain exists as a safe repository for the data to which you can deposit and from which you can withdraw. And as I said, license fees are tiered, and we have introductory rates for academic licenses, research centers, and corporate clients to start to secure their data by using the gene chain. So thank you very much, and I think I have some time for questions. I have 5 minutes for questions, if there's any. Yeah, is there a microphone for the questions or no? Yeah, I can hear you if you yell. Yeah, we're using an Ethereum base, but we have a hybrid gene chain. So we're using a couple of different tools right now to do it, and we have 2 blockchains running. So it's a hybrid form of Ethereum. Now that's going to be for the gene chain coin. So what we think is that people who are interested in buying a license but don't have good power for mining are still going to need the coin to do transactions. So others might mine and exchange that token to them to complete those transactions. Okay. Other questions? As I said, we're at booth 122, and we have a couple of gaming laptops because they got GPUs in them that are good at parallel processing and good for mining, as you know. So you can stop by and see that in action. Thank you very much.